Hello everyone, welcome to another video. And in this video I did create some sample project file where I have different installations. So we have ducts, we have pipes, we have cable trays with fittings, and we also have cable tray without fitting. And in this script I actually want to show you how you can just pick any pad for some installation, and you can force Dynamo to give you an answer what is the total length. So you don't want just the length from the straight sections, you also want the length for the fittings, and also if you have some kind of accessory on your installation, you also want to know their length. When you will use a script like this, well, for the cable trays, you can pick when you decide that you need to model cable trays. Either if you want later to schedule everything with total lengths, you can pick cable tray without fittings. But if you for some reason want to go with cable tray with fittings, then the schedule will just show you the total length of the straight sections, and you will have the number of fittings. So you will not be able to, for example, pick like some pad like that, and for that pad you want to know what is the total length. Again, if you are using cable trays with fittings, you cannot do that. For the ducts and for the pipes, usually you don't need a script like that, but maybe if you're running some pressure drop calculation, maybe you will need to use something like that in order to see that particular pad or that particular section, what is the length. So let's see how this script works. I will run it a couple times through the Dynamo player. So the only thing that we need to provide for this script is some selection of the elements. Sometimes selecting everything it's very easy, but if you want to go from here, I don't know, to here, maybe you will have a couple of more clicks to do in order to select those elements. But for me it is like I will click on the one element, I will hover just over the some end element, and then I will press the tab with Control key and the left click. I will just select that pad, and basically that's it. For me it is one more step. I would isolate those elements. Of course you can use shortcut keys to do that. Over here I did just show if you want to go with the user interface. And now when you did select all the elements which you need and for which you want to know the total length, now you can click over here to select everything and just run the script. And the output from this script is a pop-up window, like this is some installation length calculator, and the total length of the selected elements, it's this is a metric sample file, it's almost 25 meters. Of course you can convert millimeters to meters, or you can use this for imperial system, but for me it is like, okay, this is what the Dynamo will produce. How actually Dynamo calculated also the length. So let's just run it one more time. So let's try to check this. So this is 24 point, let's say 7 meters. And now if we go step by step and we want to check this, where is the calculator? We want to check that result. Of course, what we have for the result must be larger from what we will have when we look at just straight section. So this is 1.9 plus, let's say 2.8 plus if we just take a look of the length parameter for all straight sections, when we sum everything, we will have 23.4, and with all those fittings, we did have the total length of 24.7. So it looks like that is okay. We can also test one more thing. Of course, we can now maybe select this and go up to here. We will isolate this just to show that it will work also for the duct. We will not try to see if this is okay or not. I think the script is okay, but the things which we can check over here. So over here we have just one cable tray run. So this is the cable tray without fittings, and for cable tray without fittings we can always schedule that entire cable tray run. And now I will show you what my script will produce if we select all elements, and then I will explain you how my method actually works. So over here we can just select everything. We will click run. So once again, so this is like 26.3 meter, the total length. And from the other hand, did I create? Yes, I did. Okay. From the other hand, like the total length for the cable tray run, it's 25. So actually over here, Revit says that we have 25. Now, where is that difference of 1.3 meters? I will try to explain you now. So, for example, if we take a look this path over here, so we have some cable tray. I will try to draw similar setup over here. Then we have vertical part, and then again we have some horizontal part. What was my idea when I did try to calculate total length? Of course, for those elements which are like straight section of cable tray, pipe, conduit, or duct, you can always retrieve that length parameter, and for those elements you don't have anything much to do. So for all those straight sections, you will always have information what is the length of those sections. The problem will be when you want to know what is the length for the fittings. And over here, with some fittings, you will have some big margin of error. With some other fittings, you will have no error. Why? Because over here, how actually we have this in the Revit, over here, we have arc. Here we will also have arc, and that is why you will have in the Revit schedule less length than what I have. Why? Because I did calculate the length of the fittings in the following way. I know where is the connector of the fitting, and I know if over here I did select something for which I want to connect that fitting or not. Also, I know that end point for each fitting, and the things which I also know when I call get location node for the fittings is this point over here. So now, because I don't know if this is an elbow or not, and I don't know which radius you're using, if I did have enough time, I probably could implement that, but I just didn't care. So the way how I did calculate the length, basically I know this point, I know this point, and I know this point in the middle. I did sort all those points for each and every fitting, and then I will create basically a polycurve. So I will have a polycurve which consists of a couple of curves, and that will be start from here, go to here, that will be one line, and also start from here, go to here, that will be a second line. Both of them will be in the polycurve, and for the polycurve I can also retrieve what is the length of that polycurve. Then from one side I will have the length of all straight sections, and also I will have the length of all fittings. I will sum up everything, and I will in that way have my total length. When I say you will have also some fittings where you don't have any margin of error, and that you will have in a case when you have T or when you have cross. So for example, if I did select something like this, so over here we have start point, we have middle point, and also we have end point. So this is actually the length of the fittings, and me and also Revit, for this case, for this fitting and for the cross, we must have the same length. So in cases when you have elbows, my calculation of the total length will be slightly above what the Revit will calculate as for the length. But again, I will always have a little bit more than the Revit has, and that is like, I don't know, maybe 5% of the total length. So you will always be a little bit more on the safe side. And I think that is good, and that is why I didn't force to calculate, let's say, more accurate length for the elbows. Pretty much that is it. Now I will open this script in Dynamo just to show you basically how simple that script is. You can feel free to use it. Okay, this is the entire script, believe it or not. So let's run again. Let's run the script for this example over here. So this node over here we did declare to be an input, so you can access this node through the Dynamo player. And okay, now we will run the script. Again, we have same information, that is okay, but let's just follow the geometry. Okay, and over here you can see what I just did mention. So and over here we have just elbows, so my margin of error is probably the biggest over here, because you don't have T, you don't have cross, you have just elbows. And over here you can see, maybe we can try to rotate in a similar way. So this is something like this, I would say. Yeah, I think this is it. So for this elbow over here, I will have start point, end point, and point in the middle, and I will go with like line over here, but that is actually a polyline. And I will have slightly bigger length than what you have over here. It is also with these elbows which are probably 45 degrees. So again, start point, end point, point in the middle, and that's it. Okay, that is geometry. Let's put it somewhere over here. So over here we did select the elements. We want to retrieve their location. With this node we will actually retrieve all those points in the middle. For like straight sections and straight part of installation, we will retrieve lines. For lines we can immediately call curve length, and we will have information what is the length of any straight part of installation. On all pieces, when I did call curve length, and over here I have a point, I will receive a null value because point doesn't have a length. That is okay. So we will use that method in order to separate now the parts for which we already have length, and this another part of the story where we have a point and we need to find the other 2 points and to connect everything. So that is okay. Looks like we don't need this one. Over here we did took all those lines, so we will continue with outport. We will say, okay, for those elements for which we can immediately retrieve the length, we will sum up that. That is okay. For the points we can go over here. Now I will not go like element by element, but I will try to explain what is like general logic over here. It can happen that you did select some elements, for example, in the part of installation, when, let's say, if I select this element over here and I want to go up to here, so over here in this path I have like T fitting, I also have a cross, and when you ask for the connector information for this T fitting over here and for this cross over here, you will retrieve information that you have some elements on all 3 sides, or in this case on all 4 sides, but you need to check and you want to proceed only with elements that are included in your selection. So you don't need actually this point, because when you ask for the cross and you say, okay, I want to know the connector for this cross fitting and I want to know the points for that cross fitting, it will give you all 4 points, but actually you don't need this point over here and you don't need this point over here. In previous cases you did need only this connector over here and this connector over here. So what I'm trying to do over here is actually I want to take a look once again for those straight sections, what IDs I have in my selection, and because for the T's and for the cross I will receive multiple points. I want to check if all those points are actually the points which I will use in this selection. So connected elements are probably a lot of elements. Those are like my elements which I pick up in the selection. That must have a match, and I will only took the points for which I did find a match. Okay. And over here actually what I want to do is actually over here I will have start and end point for each fitting, and over here I will have once again that middle point of each fitting. Over here now I need to sort everything, so it must go in a way like start, middle, end, start, middle, end. Why? Because you will then create those polycurves, and if you have some weird let's say sorting over here, you will not have like the closest and smallest lengths. You will then go probably something like this. It can happen if you didn't sort in a proper way, that your polycurve will go from this point up to this point and it will go over here, so you will not have what you want to have. So that is why you need to sort all those points. Okay, so now when you have for each fitting a polycurve, now again you can retrieve the length. It is not like that you're interested in the length of each fitting individually. You want again to have a sum value for all fittings. So over here you have like sum for all straight sections, and over here now you will have a sum of all lengths for the fittings. Now we will just combine those two values, and over here I have a couple of nodes in order to try to say that like this opening sentence should be like the total length of the selected elements is, and then what is the value, and then also I want to say that in this case my units are millimeters. So over here I will create a list. I didn't know how to do this like differently. I think that you can do this in less nodes, but in the moment when I did create this script I didn't have any other idea, so I use basically the same node twice. And over here again you have a list, and it cannot be a list, it must be just a string. So over here we will always have just one item, and we will call that, it will be a string, and over here we have just some simple Python script which we'll need to create pop-up window. So this is what will be a title, and this is like installation land calculator, and this is what is the message, and we will show that to the user, and basically that's it. That's it. Thank you for watching. Bye.